Okay, so I've started a recording session for the next course, which is the PS. So please, let's all stay tuned. Okay. Okay, so chapter 2, as I said, will cover the PS network, and we are going to look at introduction to the PS network architecture, what makes up the GPRS network nodes, and then also the EPC network nodes. Okay, so moving right along, the PS network consists of two networks. Okay, we have the GPRS network and then the EPC network. Now, the GPRS network provides the packet data services to GSM and WCDMA systems. The EPC provides the packet data services for LTE and non-3GPP networks, including trusted non-3GPP network and untrusted non-3GPP network. Okay, so basically what this part is just trying to say is that now we have the packet core network. The packet core network is basically transmission of bestie connection in which such short amounts of data are exchanged between users over long time periods or for frequent transmission of big data volumes. So in this case, no physical resources are dedicated for the purposes of the connection. No connections are dedicated, unlike the CS whereby we had connections dedicated. Okay, in the PS we do not have any connections that are dedicated. The connections are shared between all the users. All right. Now, this type of network, which is a packet core network, are two types. We have the GPRS, which handles the GSM, and then the WCDA, or the 2G and then the 3G network. Then we have another part of the same packet core network called the EPC, which handles the LTE, handles the Wi-Fi, handles connections that are not based on the standard 3GPP networks, such as GSM, such as WCDMA. Any other type of network would connect through the Evolved Packet Core network. Okay. Now, the Evolved Packet System, EPS, consists of three parts. We have the UE, the LTE, and then the EPC. So what we are learning is just an aspect of the EPS network. The EPS network, as I told you, consists of these three different parts. But then what we are interested in at this moment is to be able to learn about the EPC network. Now, both of these networks, that's the GPRS and then the EPC networks, provide solutions for IP communications between the UE and then the PDN network or the packet data network, such as the internet, the corporate LAN, machine-to-machine learning, IoT networks, and all those networks that you can think of. Okay, so how the user equipment or the mobile station will be able to communicate with the internet has to be able to go through what we call the EPC or what we call the GPRS network. And basically, if I'm upgrading from the GPRS network to the EPC network, right, I only need software, meaning that the nodes that are being used for the GPRS and then for the GSM network, if I want to use it for the LTE or for the Evolved Packet Core network, what I require is just software upgrade to be able to handle that aspect of okay, so that's it for the introduction. Now, going into the different nodes, right? Let's talk about the GPRS network nodes. We have the SGSN. The SGSN is the primary component of the GPRS network. The SGSN, the full name for SGSN is what? The 7 Gateway Support Node, right? Now, what this node does is that it anchors the user towards the RAN or towards the access network. So the network, the node that connects to the access network or the RAN network, right, is the SGSN network. Okay. Now, what it does is that it forwards the incoming and outgoing packets addressed to and from MS that is attached within the SGSN service area. Okay, so packet routing, transfer to and from the SGSN service area, handling of the location of the subscriber, mobility management, all those things are being handled by the SGSN. Now, other functions of the SGSN is the ciphering and authentication, handles the session management, handles the mobility management, and then logical link management towards the MS. It connects to the HLR, MSC, BSC, the GGS, and other nodes, and then it handles the charging or the output of the billing data. Okay, so that is one aspect or one function of the SGSN. Now, the SGSN, right, is akin. The SGSN is akin to what we call the MSC in the CS core network. So what the CS core MSC does in the CS core network, that is what the SGSN does and more. Okay, because the SGSN, apart from handling the signaling, it also handles the packet or the transmission of the traffic itself, unlike the MSC, which only handles the signaling or the control of the core. Another important node in the GPRS network, right? If I have not mentioned, the GPRS stands for the General Purpose Radio System. Okay, that's what the GPRS stands for. General Packet Radio System. General Packet Radio System. Okay, now the SGSN, like the GGSN, right? The GGSN stands for the Gateway GPRS Support Node, and it's also a primary component in the GPRS network. Now, the node that connects the subscriber to the outside internet or to, let's say, the corporate LAN is the GGSN, right? So if I want to be able to communicate to the internet, the node that makes it possible for me to connect or anchors the internet to me or anchors the ISP, the internet service provider to me, the user in the network, is the GGSN. So as SGSN anchors the access to the user, the GGSN anchors the internet to the user. Okay, so the GGSN therefore contains access functions that interfaces with the external ISP, which I've mentioned, such as routers and radios. Radios is a way of authenticating a subscriber in the packet core network. Okay, for most of the time, this functionality is not even used anymore, you know, because we now have a better way of doing that, which is the diameter. Okay, we will talk about that in the I think from tomorrow when we are talking about the protocols. We will mention what the diameter is and then what it does. Now, when it comes to giving the subscriber an IP address, the node that handles that is the GGSN. All right, so as I said, which is used for security purposes, IP addresses allocation. From the external IP network point of view, the GGSN acts as a router of IP addresses of all subscribers served by the GPRS network. So in effect, the GGSN is a router. What is a router? A router is a layer 3 node which sends packets to and from a network. So that's what the GGSN does. But then it has more, it's more specialized, or it has more specialized functions, such as anchoring the internet to the user. It also has the functionality of providing authentication through using the diameter or the radius. It also has the functionality of providing the IP addressing for the subscriber. So provision of the IP address to a subscriber is being handled by the GGSN. Other uses of the GGSN, that's the gateway support, gateway GPRS support node, right? Handles the session management. So the apart from it being a router or it being a platform node that is handling the packets in and out of the network from the internet to the subscriber, it also handles the session management. In order for me to be able to set up my packet call, I need to be able to have a session from the GGS and all the way to the UE. That is being managed or handled by the GGSN. Okay. The functionality of associating the subscribers within the right SGSN. So a network may have a number of SGSNs connected to it. How will the GGSN know which node or which SGSN that subscriber is on, right? So the node that makes it possible for us to be able to communicate to the right subscriber is the GGSN. And then it also handles the charging of the subscriber. That's output of billing information and other things. So in the pictorial view, right, let me try and then put this in a picture view for all of us to see. Control L. So here we have the GGSN, right? This GGSN is connecting to the external network called the PDN or the ISP, right? Now, this is what anchors this user here to the internet. Now, there is also another node, main node in the GPRS network called the SGSN. Now, the SGSN is what connects to the access network. So if a subscriber wants to connect to the packet call network, the first point of contact of the subscriber in the packet call network is the SGSN, because it's closer to the access part of the network. So this is how the connection is done. We have the SGSN connecting to the GGSN, and then this one connects, the GGSN connects to the external networks, the PDN. Now we have the two different networks here. We have the GSM network, we have the WCDMA network, right? So these two networks connect to the SGSN network through the RBS and then the BSC over the GSM network, and then through the RBS and RNC over the WCDMA network, which will be divulged or talked about more in the run and delivery of the course. Okay, so this is it for the GPRS network. These are the main nodes in the GPRS network. Another key node, which is not mentioned here, which sits sometimes between the SGSN and the GGSN, is the DNS. Okay, the DNS is the domain name server and is a client to server system using the TCP IP network. What is the DNS? The DNS is simply a node that changes, or it's, let me read it. The DNS is used for high level application to map the alphanumeric names to IP addresses. So for example, let's take for example google.com, right? Now, if I want to go to google.com, the google.com is just a name, but then behind the google.com is an IP address, and the networks use the IP address to communicate with each other. So if I want to connect to google.com or cnn.com or any of these known URLs, the node that is able to map the URL such as cnn.com to its IP address is the DNS. Now, there are three different parts of the DNS, which we will talk more about in tomorrow's slides, in the module 2 slide. Now, we have the internal DNS, we have the external DNS, and then we have the internet DNS or the primary DNS. What are they all used for? The IDNS, right, is used for communication between within the same network, within the same PLMN, right? So a subscriber has an access point name, which references the network that he wants to connect on, right? He wants to be able to connect to maybe a particular network, right? So on your phone, you will see something called the APN. Now, the APN is what is the alphanumeric name, maybe internet, or in some networks, they will give it a special name, such as, let's say, gprs.net or something. They'll give it a name. Now, then that name can be mapped to an IP address in the network. And normally that IP address in the network is the GGSN, right? So the APN is just a reference name for an IP address or the GGSN in a network that the subscriber wants to connect to. Okay, so that is what the IDNS does. The IDNS converts internal network names such as the APN to an IP address or a reference network in the same network. Now, the eDNS is the external DNS, all right? It's also a functionality of the DNS, which is able to map the a subscriber that is roaming in your network. So let's take, for example, somebody comes from Nigeria to Ghana network, right? And he wants to be able to browse, which is very expensive. I mean, most of the time, nobody does that. What happens that when you come into the country, you buy a new SIM. But assuming this guy is loaded and he wants to be able to connect to his home network, he's from Nigeria, he's in Ghana, he still wants to connect to his network. The DNS that would be able to convert the APN name to the IP address that he wants to communicate to in his network, that is the GGSN in his network that he wants to talk to, is the eDNS. So the eDNS is primarily a node that maps the access point name to external GSNs in the home network of the subscriber that is roaming. Okay, then we have what we call the PDNS or the internet DNS, right? This internet DNS, let me show you where it sits. This internet DNS normally sits at the edge of the GGSN. Okay, so what it does is that the names that the URLs that we want to visit, like wikipedia.com, teams.microsoft.com, all those URLs or alphanumeric names, this is the node that is able to change those nodes to an IP address that the ISP would have to communicate to, so that the subscriber can have the packets being transmitted from that node in the node that the subscriber wants to talk to, or the URL or the network that the subscriber wants to talk to all the way to the subscriber. Okay, so that is what the PDNS or the internet DNS does. We have the IDNS, which is able to handle the alphanumeric mapping of the APN, or if you, I'm giving some more information here. Just a moment. Yeah. So the APN to the GGSN IP, you know, the RAI to the SGSN IP, the RNC ID to the SGSN IP. All this is being handled by the IDNS. Then we have another DNS, which is able to resolve the APN to the GGSN IP address of the external network. such as the Nigeria network, right? So MTN Nigeria is the APN. He wants to be able to talk to his network. That APN Nigeria would be converted to an IP address, which is an external network. All right. So that node which handles the mapping or the conversion or the resolution or the resolving of this alphanumeric name to the GGSN, external GGSN, or the roaming party GGSN, right? That node is the EDNS. Then the last DNS functionality is the PDNS, which I told you sits at the edge of the GGSN, is the PDN or the internet DNS. Now, this internet DNS is what converts the URLs that we normally use for internet browsing, google.com, yahoo.com, gmail.com, all those names to IP addresses is being handled by the PDNS or the internet DNS. And most of the time, some networks have their own PDNS because it's very good for security purposes. I mean, when you have your PDNS sitting outside of your network, you can have a lot of attacks in the network. But when you have it internally, it's closer to the network, meaning less delays, and then also it's more secured. You reduce a lot of DDoS attacks from the external, hackers. Okay, so normally you will find it sitting at the edge of the GGSN. The I and then the D, the I and then the E DNS sit between the SGSN and then the GGSN. So you have the I and E sitting on the GN plane, and then the GGSN, the PDNS or the internet DNS sitting on the GI plane. That is between the GGSN and then the PDN. Now, let's move on to the second part of the network, which is the EPC network, right? The Evolved Packet